So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So welcome to yet another lecture of binary tree, right? So the important concepts up till now, important concepts have been finished. Important concepts are done. So a big round of applause for all of you guys who have completed the series up till now. Important concepts are done. Now some practice is required, right? How to think extensively. How to think extensively. Like think extensively. Now, only one thing will remain common in the forward questions. I will like now upload like 14 to 15 questions more, and then I will just upload the practice questions then. These are not practice questions, these are also mandatory questions to complete the series to master binary trees, so do not skip it. Now, first thing is you have to think extensively, and second thing is that you have to remember traversals. At wherever you see the question of binary tree, you need to know that I have to solve it using a traversal. Now, which traversal? That is the thing, right? Now, the today's question is route to leaf path, right? Route to leaf paths. Although it is lead code easy, but still some people are not able to do it. So no problem. It is not that easy that is mentioned on the lead code. Let us see what are the questions. The question says that you have a tree. Obviously, this is the route as it is obviously seen, right? Now, it says that identify all the leaves. Identify all the leaf nodes. Okay, no problem. Leaf node is the one which doesn't have a left or a right. Okay, so this is the leaf node, this is a leaf node, and this is a leaf node, right? And then it says that return all of the paths from root to every leaf node. That is, for this, for three, what is the path? It is 1 to 3. It is first string. Second string is for 5. That is 1, 2, 4, 5. Right? Then for 6. 1, 2, 4, 6. Right? And return it as a vector. So this is a vector of 3 elements. That is 1 to 3. Then 1, 2, 4, 5. Then 1, 2, 4, 6. Right? And this is your answer. This is your answer. How will you solve it? How will you solve it? Right? Okay. So if I think extensively, then it is a traversal only, right? First thing I have to figure out, it is getting done by traversals. Now, which traversal? So my answer to your question is any traversal. Not any, I will say pre-order, something sort of pre-order. Why? Why? My approach says that if I'm standing at root, let me copy the tree, right? This tree is given to me is 1, 2, 3, 4, 5, and 6, correct? Right? These are the leaf nodes 3, 5, and 6. Right? My approach says, first of all, I am standing at root because root is given to me. So, first of all, standing at root. In all the questions of binary, you're standing at root. Right? So, you have to do all the operations with root. Okay, standing at root. I say, make a string, and add it to it. Okay, one added. Right? Now from this route, I have two options. I can go towards 2, I can go towards 3. Okay, so this string say I will go towards 2, I will go towards 3. When I go towards 2, I will add it to the string. That is, this string becomes 1, 2. Okay? And 3, when goes to the 3, it will become 1, 3. Right? Now, as soon as it becomes 1, 3, I will check if is 3 my leaf node. Is 3 a leaf node? Is my current node a leaf node? First question you have to ask. For 3 it says yes. So if yes, push into the answer. Push into the answer. So how will I push it? I will say that I have a global variable of vector string answer, and I will push into it. So this has been pushed. So this actually now becomes 1 comma 3. This contains 1 comma 3, right? 1 to 3. Now talking about 2, and I will also return this call returns. As soon as you push it something, you return, because obviously from the leaf node you cannot go towards left, you cannot go towards right. That is the concept of a leaf node. Coming to 2, 2 also has two cases. It can go left, it can go right, right? So when it goes towards the left, it is a null node, and for a null node it is not a leaf node. That is, 2 has a right child, that is why it is not a leaf node, but 2 doesn't have a left child. So what will happen? It will return as it is without pushing anything into the answer. It will return as it is, right? Coming to 4, When it comes to 4, it will say that add it to the string. That is 1, 2, 4. Is 4 a leaf node? No. 4 also has two children, 5 and 6. When it comes to the 5, firstly add the string. So 1, 2, 4, 5. And here it becomes 1, 2, 4, 6. When it comes to 5, it will see 5 is a leaf node. So add it to the answer array. That is 1, 2, 4, 5 is the answer. Add it and I can safely return. And for the 6 also, 1, 2, 4, 6. It is added and returned. Because the both call return, you can return here. And because both call return for 1, 2, it will return. And because the both call for 1, it will return to the driver function. And you can see my answer array does contain the three values I needed. My answer array does contain the three values I needed, and that's all. So what is actually happening? If I try to do, suppose this is my driver function which is asking for a vector string, right? Suppose this is my driver function and it will give me the root, of course. What will I do? I will say solve for, send the root because that is the first element I have, send the root along with the empty string along with an answer array, right? You will have to make an answer array here, something like this, vector string answer, or you can keep a global variable of answer as well, so you don't have to send in every recursion call, right? And after the call finishes, return answer, right? Now what will happen for the solve? What is solve doing? Solve is actually void type. Why void? Because it is not returning anything, it is just pushing into the answer array, right? Void solve, what is it taking? It is taking the root, it is taking the current string, and it is taking the answer array by reference. So vector string, and don't forget the and answer. Why and? Why answer array sent by reference? Because I have to change, see the reflection here also, because I'm returning from here, right? What will happen? First case, if root equals to null, I cannot do anything and I will just say return. I don't push anything also, right? Otherwise, if root left is null as well as root right is null, that means I have reached a leaf node, and that means I have to push something into my answer. So answer dot push back your current string and then return. But wait, is this current right? Can I push something like this? No, because I have not pushed the leaf node into the cut. So what will happen? Here, at this point, what will I do? I will have to write something like this. So if my current dot length is not equals to 0, then do something like this. Current plus equals to, first add the arrow, right? And then add the, after this it will come something like this, current plus equals to to string value of root value, right? What is actually happening? So you see that when I come to 1, I made the string as 1. When I come to 2, firstly I do the 1 to 2 operation and then I go, right? For 3, first I do the 1 to 3 and then I check if it is a leaf node or not, right? So first add the string. And why have I done this one? Because if you see in the answer, I have to add arrows also, right? So if for the first string, for the first alphabet, for the first value, I do not have to add an arrow before, right? I have to add only afterwards. That is why I'm checking if it contains something, then arrow has to be added. Otherwise, arrow does not have to be added, right? And if it is a leaf node, then push the current string after doing the changes, right? Otherwise, if it is not a leaf node, then go to the left. That is solve for root left with cur and answer, and then solve for root right with cur and answer. That's all. This will return you everything. I know for some people it was very easy because it is just using recursion. I believe that, but this is an important question if you're going for the binary trees mastery, right? Let us see the code for it real fast. Alright, so here is the coding window, but before starting with it, it's my sincere request to you to please subscribe to the channel and please follow me along. So vector of string answer is to be made first, right? And then just solve for the root, starting from the root, send an empty string and send answer. And I mean it, when the function call returns, return answer, right? Now all the things have to be done by solve. So void solve tree node star root string cur This has not to be made by reference. Why? Because we are if we change anything in the children functions, then it will just ruin the already inserted values, right? So string cur and then vector of string and answer. Why and? Because I have to see the changes here. The changes I make here, I have to see the changes here, right? Now first case, if my root equals to null, in that case return and then do nothing. Otherwise just add something. So if my cur dot length is not equals to 0, then cur plus equals to, it is a string, sorry, right? Then cur plus equals to two string value of your root's value, right? And now make the operation. So if my root is a leaf node and root, right, both of them are null, that means it is a leaf node, then just push the value. So answer dot push back the current string and return. Otherwise go for further investigation, that is solve for root left cur answer, solve for root right cur answer. That's all. But at last return, right? Why return? Why I'm mentioning return everywhere when there is no needed? This is just a good coding practice, right? Let us try to run it. Hope it will work fine and will not give any error. It is working fine for the sample test cases. It will work fine for the hidden test cases as well, I guess. Also to mention that this time complexity is O of n because I'm just traversing, right? You can see it is evidently a pre-order traversal. You are going from, you are exploring the root first, then the left function, then the right? So it is also getting solved by a traversal. Getting accepted. So thank you for watching. Hope you liked it and make sure to watch the next video as well and complete the series to master binary tree for your OAs. Thank you. Have a nice day.